All right, so number 15 is nothing more but a bunch of gobbledygook, and so I'm going to walk you through the steps. You're going to follow the same steps in 16. And actually, you know what I'm going to do? I'll do both. Okay, so here you have 1 over x plus the change in x minus 1 over x. We're looking for the limit as the change in x approaches 0 from the left. Okay, so what do we know about fractions when we subtract them or add them when we don't have the same denominator, right? We need to get a common denominator. So I'm going to highlight these for a moment. And we're basically going to multiply this one up here, this one up here. I'm going to multiply these straight across. So this is going to give me x minus, notice the parentheses, this is for this part of the equation, x plus the change in x. All of this is over the product of this, which is x parentheses x plus the change in x. Now we're still dividing by change in x over 1. So in essence, we're going to keep change flip. So remember, this part of the equation is our denominator. That's this part here. I just rewrote it with a 1 underneath. So we're going to end up with x minus x plus the change in x. I'm going to write it first so you can see it, and then we'll reduce it. X parentheses x plus change in x. And we're going to multiply this by 1 over the change in x. So at this step, what we're going to do is we're going to multiply it. So actually, I'm going to distribute this out first. All right, so I get for the numerator x minus the change in x times 1, leaving me this value, which reduces to just the negative change in x. That's all I'm left with at the top, because technically these two cancel out. And I kind of skipped a step, but remember, we're multiplying times 1, so this value times 1 gives you this. Okay? Now all of this is over x times x plus the change in x, and we're still multiplying this. We can actually go back and take away that multiplication part and just rewrite the whole thing. So as x approaches 0, we're going to end up with, because remember, it's the change of x is approaching 0, we're going to end up with these two canceling out top to bottom. So we can actually do that first. Let's go here. So this is going to cancel with this going across, kind of simplifying your fraction a little bit. And you're going to be left with negative 1 over, because what canceled was this part of the function, not the negative. If you notice there, okay? So negative 1 x times x plus the change in x, that's our denominator. And we're still looking at the limit of the change in x as we approach 0 from the left. And so if we were to distribute this x, now remember that we're going to substitute in a 0 here, we end up with negative 1 over x squared. Okay, and just for the sake of going through the steps, x times x is what gives us the x squared. The negative 1 is this part of the equation. All we're doing is bringing it over here. That's why, hence, negative 1. And if you recall, this part of the equation is approaching 0. So it's like changing this to x squared plus 0. Well, x squared plus 0 is just x squared. And so your final answer is negative 1 over x squared, and that's your limit for this particular function. So it's very easy to get lost in this one. This is one of those questions that's a time buster, so if you're taking an exam and you see this question, you may want to consider doing the ones you can answer quickly first, and then go back and answer that one. Okay. Let's take a look at number 16. Number 16 has a lot of steps as well. So in this one, we're going to look at the limit as the change of x approaches 0 from the right-hand side. The equation that we have is x plus the change in x squared plus x plus the change in x minus x squared plus x, all of this over the change in x. So there's a couple of things we want to do. Step 1 is we want to definitely FOIL this out. Step 2, I definitely want to distribute out that negative. And so those are the first two things I'm going to do. So using FOIL, x times x is going to give me x squared. If I multiply x times the change in x, I'm going to end up with positive 2x change in x. Okay, and then the last part is simply going to be plus the change in x squared. Okay, and keep in mind all this is one term. I'm simply going to bring down the rest of this equation. So if you notice, I'm going to bring down the plus x plus the change in x. I'm going to go ahead and I'm going to distribute that negative. So this will become minus x squared minus x. All of this gobbledygook is over the change in x. Okay, and same thing applies as far as the limit. So you can rewrite it if you want to. So the limit as a change in x approaches 0 from the right. All right. Now at this juncture, we want to try to eliminate as much as possible. So if there's anything that'll cancel, we want to go ahead and cancel it. So you're going to notice that, let's do these in pink. Pink is always a good number, good color. X squared is positive and negative x squared, that goes away. What else cancels? Positive x cancels with negative x, that goes away. What am I left with? I'm left with 3 little terms. I'm left with 2x change in x, that's this part of the function, plus the change in x squared, that's this part of the function, and then plus the change in x that's left over here, which is this part of the function. So all of this over the change in x. Okay, so now we reduce. So if I'm looking at this equation, and now we're to divide each of these terms respectively by the change in x. So as an example, say I took 2x over the times the change in x over the change in x. Guess what's going to happen? I'm going to be left with 2x. If I do the same thing here, plus the change in x squared over the change in x. Notice that this is technically to the 1 power, this is to the 2 power, leaving me 1 change in x. So these two reduce. 2 minus 1, hence 1. Okay. And lastly, plus, again, the change in x over the change in x, anything over itself is plus 1. Now, what do we know? We know that the limit as a change in x approaches 0 from the right hand side. So 2x plus 0 plus 1. Final answer, 2x plus 1. Alright, so that's 15 and 16. Quite lengthy.